Hello everyone. Now we are going to learn about Diffie Hellman key exchange algorithm. It is a specific method of securely exchanging cryptographic keys over a public channel. It is neither an encryption or decryption. It is used to share the keys between sender and receiver. It follows asymmetric key cryptography. Uh, it allows two parties that have no prior knowledge of each other to jointly establish a shared secret key over an insecure channel. At the end of the communication, both sender and receiver have the same key. If the shared secret key between a sender and receiver is same, then we can say that message is sent securely. Next, Diffie-Hellman algorithm consists of 5 parts: global public elements, user A key generation, user B key generation, generation of secret key by user A and user B. Coming to global public elements, we'll generate a prime number which is represented by Q, and alpha should be less than Q, and it is also a primitive root of Q. Then user A key generation. Here we will generate a random private key which is less than Q, that is a prime number. So private key of A represented by XA. Then we will calculate public key of A which is represented by Y. Here's the formula. We can calculate the value of the public key. Next, user B key generation. Here also we'll generate a random private key which is less than Q. It is also represented by XB. Then calculating the public key of B, which is represented by YB. Here's the formula. YB is equals to alpha power XB mod Q. Then we will get the value of public key of A, the public key of B. Next, generation of secret key by user A. Here by using this formula, we can generate the secret key of A. Here k is equals to public key of B to the power of private key of A mod Q. Here generation of secret key by user B. Here secret key of B is equals to public key of A to the power of private key of B mod Q. So that secret keys will be generated from both A and B. Here we can see the block diagram. First, in user A, we'll generate a random private key which is less than prime, which is less than prime number, that is Q, and we'll calculate the public key of A. Then in user B, we'll generate a random private key of B, and then we'll calculate the public key of B, and both the sides will calculate the secret key. Here comes the Diffie-Hellman example. Here it is a prime number. We'll take any prime number. Here we will be taking Q is equals to 97 and alpha is equals to 5. So 5 is less than 97. So the condition is passed, and 5 is also a primitive root of Q. Next, we'll generate a random private key of A, that is 36, and a random private key of B, that is 58. Then we'll calculate the public key of A, which is y A is equals to formula alpha power XA mod Q. Here we can see alpha power XA mod Q. That is, so here we'll get the public key value as 50. So next we'll calculate the public key of B. Here also we'll follow the same formula. We'll get the value as 44. Next, we'll calculate the secret key of A. So we can see that here the public key of B to the power of private key of A mod Q. So public key of B is 44 to the power of private key of A, that is 36 mod 97, which gives 75 mod 97, and the answer will be 75. So shared secret key of A is equals to 75. Next we'll calculate shared secret key of B. Here y power y to y a power xb, that is public key of a to the power of private key of b mod q. So public key of a is 50 and private key of b is equals to 58 mod 97, which gives 75 mod 97. So the answer will be 75. So here we can see that secret key of a and secret key of b is same. So we can conclude that shared secret key is same and the message is sent securely. Here we can see the code, C programming code for Diffie key exchange algorithm, Diffie Hellman key exchange algorithm. Here we'll take standard input and output as the headers and math which contains various mathematical functions. And in the main function, we will declare alpha and root, that is q, which is alpha and prime, sorry, prime number, which is represented by q. So here we should follow the condition that alpha should be always less than q. Here we will declaring alpha and q, that is long int. We will declare with long int to store large values. Then we will scan. We will read the values of alpha and q. Next, we will declaring private keys of both the users, that is a and b. Here also we will take long int xa comma xb. Then we will scan both the private keys of xa and xb. Next, we will declare uh, public key of a, public key of b, and secret key of a and secret key of b. Next we will calculating the public key of a, that is ya is equals to alpha power xa mod q by ya is equals to long in power alpha comma xa. In power function, we'll keeping the two elements alpha comma xa, that means alpha to the power xa, where the value is stored in the form of long int. So by this line we will get the public value of the public key. Then now calculating the public key of b, that is yb is equals to alpha power xb mod q. Here also we will take long int power alpha comma xb. In power function, we will give two elements, that alpha comma xb, that means alpha to the power xb, which gives the value of the public key of b. Then we will calculate secret key of a, that is k is equals to yb, that means public key of b to the power of private key of a mod q. So we will take long int power yb comma xa percentile q. So in the same manner, we'll calculate the secret key of b, that is kb is equals to public key of a to the power of private key of b mod q. We'll get the secret keys of a and b. Next, we'll print the statements, that is alpha is equals to alpha value we'll be reading. So next, if in the if statement, if the shared secret key between in a and b is same, we will be printing both a and b shares secret keys are matched and message is shared securely. Else, message is not shared securely. So we'll run the code. So now we have to give the values for alpha and q. So first we'll giving the value for alpha as 3. Next, we'll be giving the value for q, that which is a prime number. So we alpha, so it should be always greater than alpha. So we'll be giving 7. Next, we'll be giving the private key of a, that is 3. Uh, we can give any prime number, but it should be less than q. Next, we'll be giving private key of b, that is 5. It is also less than q, so condition satisfies. Next, so here we will get the answer. Alpha is equals to 3, q is equals to 7. So we have given here. So private key of alias is equals to 3. After calculating the public key of alias means sender, uh, alias is equals to 6. Shared secret key value is 6 by calculating. Next, private key of Bob, that is 5. Here we have declared it. So after calculating the public key of Bob, we will be getting the value of public key as 5. So after calculating the secret key of Bob, we'll get answer as 6. So here we can see that public secret key of Alice and secret key of Bob are both are same. That means the both A and B secret keys are matched and message is shared securely. So this satisfies the message is shared securely. That's it. This is called Diffie Hellman key exchange algorithm.